So you're coming up on a corner and you're driving your car and you're driving here at 30 meters per second. You have a car of 100 kilograms. That's not very heavy, by the way. And you come around this corner and it's a 50-meter radius corner. Coefficient of static friction is 0.80 and the coefficient of kinetic friction 0.60. So the question is, will your car stay on the road or will it slide? So we can determine that with the acceleration. The centripetal acceleration is v squared over r. So we're going 30 meters per second. I'm going to square that. And it's a 50-meter corner in radius. That works out to be 18 meters per second squared. So what's the force on this one? The force, centripetal, is equal to that same 100 kilogram car times that acceleration, 18 meters per second squared, and that would give you 1,800 Newton. So what's the force of this static friction? The force of the static friction would be that 100 same car there with the acceleration due to gravity, the normal force, meters per second squared, times the coefficient of friction, and this is the static friction force, 0.80. And that would give you 780 newtons. So what happens? The centripetal acceleration, the force, it's 1,800 newtons. It's larger than the static friction. So you will fly off the road. This is the force that exerts on the tires to keep the car from sliding off the road. The car will not make the corner, so slow down, or make a wider turn. So the question is, will a heavier car help hold the car on the road? How about, can a car turn with no friction on the road? If there's no friction on the road, can the car make a corner? And just remember that while you're driving, if you don't see the corner, you may see the coroner.